Hi everyone, thanks for inviting me. I'm happy to be here. Today I'll be talking about attacks on users' passwords stored in Linux memory and how to block them. I think that this topic is of crucial importance for all experts dealing with application security. This work was done by one of my students, Svetlana Golub, who worked on this topic as her bachelor thesis under my supervision. Unfortunately, she is currently unavailable. Password authentication is common for modern software. One of the common way of authentication is to calculate a hash from user's supplied password and compare it with the stored hash. For example, hashes for users' passwords are stored in the etc password file. The final step is to deallocate data used to process the sensitive information. A perfect example of authentic software is Linux GNOME Desktop, which uses GNOME keyring daemon for storing security credentials such as users' names and passwords. Security researcher Songjong Kim from South Korea discovered that GNOME keyring doesn't overwrite users' credentials located in memory. These credentials are not cleared automatically and reside in plain text in process memory. This happens because there are no routine calls to override sensitive data, probably due to unnecessary compiler optimization. As a result, any user with an appropriate privilege can extract them by memory acquisition. Let's see how it can happen. Security researcher Hunter Gregel from the USA developed a tool called MiniPenguin to extract users' passwords from the memory of GNOME keyring daemon. This tool can successfully extract ASCII passwords. Another researcher, Nicholas Verdi from the USA, has improved MiniPenguin tool and implemented a new tool called MiniPy. This tool can do both locate and remove passwords from the memory. The tool can successfully work with ASCII passwords. We analyzed these tools using different accounts in one machine. We tried to use various Unicode passwords. Here are the corresponding memory dumps of GNOME keyring daemon software. First, we proved that GNOME keyring daemon stores the user's passwords in memory even there are no Unicode symbols, and for Unicode symbols as well. Here we have two passwords with Cyrillic alphabet as well as some special symbols like euro and yuan symbols. All of them are stored in process memory. Then we checked if these two tools can reveal and override Unicode passwords. We can see that both these tools are not able to find these passwords. Also, both tools work very slowly, which is a serious drawback. To tackle this challenge, we have developed a new tool called Minidaf. Minidaf expands the MiniPenguin and MiniPy features and includes the following competitive advantages. It can locate passwords containing both ASCII characters and Unicode characters. Another challenge is to locate passwords as soon as possible. Finally, we have solved this issue and significantly improved the speed of Minidaf. We have revealed that users' passwords are located only in stack memory region, so we can skip other memory regions and focus only on anonymous regions with enabled read and write access. This helps to significantly improve MiniDaf performance. The key steps of MiniDaf are here. First, we read users' passwords hashes from etc shadow file. Second, we access GNOME keyring daemon process and enumerate its memory segments. Then we extract the sequence of bytes and calculate their hashes. If the calculated hash value is a match with one of the hash from etc shadow file, it means that the password has been found. The final step is to override the detected passwords, and finally we protect the OS. Here we can see the memory content before and after overwriting. Now attackers cannot extract users' passwords from the memory. The comparison table is here. We can see that MiniDaf has the following advantages. It can locate and overwrite passwords regardless of their alphabet, ASCII, and Unicode symbols. MiniDaf has been successfully tested using the following passwords and the following operating systems. We can see CentOS, we can see Ubuntu, and we can see Kali GNU Linux. Here is the time comparison figure, which shows how faster MiniDaf is. The source code of MiniDaf is uploaded here. Thank you.